from a code point of view, like how do you implement abstraction? That is from the user's point of view that you're saying. When you're writing code yourself, how do you make sure that your code is abstract in nature?
Can I take a guess? I'm not
Yeah,
sure.
yeah,
Yeah.
go.
So I think it would be through making private functions, which like splitting the code into different functions, so that, for example, if we have a function for in a bank, if we have a uh, account and we want to update the balance, then to get the balance there is one function which will get the balance, and to update is there is another function. That way we can abstract it, and that the function for updating the balance overall looks very readable. The function names are very readable, but the code inside is hidden inside another function which is being invoked.
Okay, I mean, if you're aware about or not, I'm not sure, but do you know how you can implement interfaces to make your code abstract? There is a way, right?
I'm not sure, but I know what interfaces are like. They're like a blueprint through which and there are also abstract classes inside OOPS programming. So those in abstract classes, we don't implement the method. We just create like a blueprint for the class, and if any class uses that abstract class, then they will implement the methods inside that abstract class. But the abstract class itself will not be implemented.
Okay, fine. Let's just jump to one of the problem, a basic one, and then we'll increase the difficulty as forward as you go, right? So yeah, I pasted one problem. If you can just share your screen and just try to look into it.
Sure, just give me 1 second. Okay. Is it visible?
Yeah, I can see it here.
Okay. Yeah.
You can minimize the screen sharing window and the bottom pop-up. You can make it smaller at least.
Yeah. Okay. Fine. So
okay, I'll just walk you through. So basically, you're given an array of integers,
yes.
right? And
Yes.
I've given you a target as well. Now you need to return me indices of two numbers such that they add up to the target, whatever target I've given. A very basic one. So, but yeah, to begin with, simple.
Yeah, I can think of a brute force approach for this, which would be just two for loops, nested for loops. Do you want me to implement that, or should I think of something more optimized?
You can do that first, and then we have to optimize it.
Okay, sure. So what I would basically do is I'll have two for loops. So first I will store the index, the size of the array. Then I can loop through it. In two nested loops. Now I will check. So J should actually be I plus 1. And then if nums of I is equal to nums of I plus nums of J, if the sum of both the elements is equal to the target, then we will return a vector which is ij, and so the solution will always exist. Is that given to us?
So second. Yeah, ideally that's the case, because I think in this problem they have not mentioned anything like that. Yeah.
Okay, so I'll just try. Yeah,
there would be one solution. Yeah, we don't need to worry about that.
Yeah, I'll just return an empty vector because if it doesn't find it here, then there is no such pair, right? Yeah. So this is the brute force approach.
Can you just submit and see?
That's working.
Okay, fine. Uh, I'm okay with the brute force approach. Okay, let me just paste another question. So we'll quickly go through several questions, and
Actually,
once
I
you
can think of some optimized approaches as well.
okay, can you tell me that?
One would be to sort the array, then have a pointer on the beginning and have it at the end. Then if the sum is larger, then we decrement the uh, higher pointer, and if it is sum is lower, then we increment the lower. And then when we find the sum, we return it. This would be O of n log n because it is sorting. And the most optimized approach I can think of would be using a complement hash map. So that hash map will store the complement values of all the values in num for targets. So it would be something like target minus nums. Then we loop through the array and we find if the complement exists in the map. If it exists, then we return the index of both the elements. So that would be O of n.
Okay, can you implement that complement method? Let's see.
Sure. So I will have an unordered map.
Yeah. So in the map, what are you gonna store in key and value?
This will be the element itself, the complement, and this will be the index.
Mhm. Okay.
And I will call it complement map. Then I would like to loop through the nums array. And I will store the index. So complement map. So it would be target minus nums of I. So what would that be in this case? So 2, 9 minus 2 is 7. Okay. And 7, 9 minus 7. Okay. And then now the map is populated. So I would again traverse through the array. I less than n, I plus plus. And I will see if the complement map
Mhm.
dot find nums of I. So if nums of I exists in the complement map, then I would like to and it is not equal to complement complement map. Then I would like to return the current index and the um, so complement with yeah complement map nums of I. Yeah, so that would be the value, which would be the index. So over here, I need to also uh, read as I. So this will store the index with the complement. Yeah. So this will return it with that. And then return an empty vector.
Okay, can you try to run it?
Yeah. Okay, so these two cases are passing, but this one is not passing.
Okay. In this case, you're returning 0. Oh, you're repeating the same number twice. You see that? 3 and
Sorry?
3. That's what you're taking. You're taking the first index for both the complements.
Okay, the answer is okay. So 3 plus 3 is also 2. Right, right. So, okay. Mm, so I should put a check here, I think, if I is not equal to this value,
Hmm. Perfect.
then I should return this. Yeah. Right. Okay. Yeah, so this would be O of n time complexity and space complexity is also open.
Perfect. I mean, this is the ideal thing to do. Yeah. Great. Good one. So now I think let me find some other question for you. Okay. Okay. I'll just paste it in the chat.
Sure.
Sorry, just a second. Yeah. This is also easy problem. And after this, we can go for something medium. Okay. Yeah. So basically in this problem, you need to figure out what is the best time to buy and sell a stock. Okay. But what I expect from you is not the time when you want to buy or sell. What I expect from you is just the maximum profit that you can make by selling the stock. And as you're aware, like the profit equals to the amount that you have sold the stock for and the amount that you have purchased that stock for. The difference between that. So that's the only thing that I'm interested in. I don't want the positions or anything else. Just to keep it simpler, that's why it's an easy problem. And yeah, you need to just return me the amount that is profitable, and you cannot buy and sell on the same day. Once you bought, only you can sell it after that day. Okay. So yeah.
Okay.
Over to
So
you.
the value in these arrays for each day. So on day
Correct.
0, day 1 it is 7, then it is 6. Okay. Um, so I think what I would do in this question is that I will store two values. One would be the minimum price and one would be the maximum profit. And then I will loop through the array and I will keep updating both the values. And after the array has been looped through, I will return the maximum profit.
Yeah.
Sure. So can I give it a try?
Yeah, please go ahead.
Okay, so I will have a mint price variable, which would be initialized to a very big value, then a max profit variable. Then I will loop through the array. Okay, so if the prices I is less than the min price, so then the min price, then it would be less than min price. Then the min price will be equal to minimum price will be equal to prices of I, and the maximum profit would be updated as maximum profit updated as maximum of the current value, but okay, no, we don't want to do that here. I think max price equal to maximum of the prices I value minus the minimum price, comma the maximum profit. Sorry, should be profit, maximum profit, and then return max profit. But just give me 1 second.
Sure.
So if prices I7 is less than the minimum price, it would be true for the first case every time. So minimum price becomes 7. Then the max profit here becomes 0. So it should not it should not compute this for like this case, because then it would so should I put an else here? If I put an else statement, then it will loop through further. If 1 is less than the minimum price, then again this is updated. 5 is not, so it calculates the max profit as 4 here. Then 3 is also not less than 1. Then 6, max profit will remain 4. Then 6, max profit will become 5. Then 4, it will be 5 only. So this case will return right. Okay, can I try to run it?
Mm, why don't you also introduce something like, okay, you can try with this and we'll see.
Okay. Because the first case is running, but the second case is not.
Correct. So because I'm saying like, why don't you also introduce another variable, which will be like your max profit, and then keep updating it while you iterate through.
I already have max profit.
Okay, you have it.
Yeah. I think this case is no transaction are done and the max profit is 0. Okay.
In case you don't see any profitable trade possible, you just return 0.
Okay, so like if max profit is equal
Yeah.
to int min, then I will return 0.
Or less than 0. That also you can get, right?
Yeah, less than 0. So right. Better. Hmm.
Perfect. Awesome. Okay, now a tricky one. You have
Okay.
already solved 3 questions, which is already great. I mean, better than most of the students. So yeah, just try this one.
Oh, actually, we did not go through this one.
Yeah,
This question.
let's just skip that. You can just go for the last one that I placed. We
Okay.
have limited time, right? Just 30 minutes left. So
Yeah. Given an integer n, return true if it is a power of 2, otherwise return false. An integer n is a power of 2 if exists xk such that n is equal to 2 of x. Okay, so if n is equal to, okay, fine.
I hope you got the problem.
Yeah.
Yeah.
So I can definitely think of like a brute force approach, would,
Mhm.
which would be simply just for each, like go through, um, have a while loop and just, okay, 1 second.
So
So if
you're
we have,
just given one integer and you have to decide whether it's coming under power of 2 or not. So first example, you see the value is given 1, input is 1, and 2 to power 0 is 1. So it means it's in the family of 2 to raise to power x, right? So
hmm.
it should be belonging to the family of 2 to power x. So that's the whole idea.
Okay, so what I can do in this is like for a brute force approach, I can just loop like loop for the powers of 2, 0. If 2 zeros to power 0 is 1, 2 to the power 2, 1 is 2, 2 to the power 2 is 4. And when the value exceeds n, then I will return false. Otherwise, if it is equal to n, then I will return true.
I know, but if I give you 1024, then you have to iterate through like 7 times, right? So it
Yeah,
would be like, I mean, if I give you like 6 digits of well integer, then that would be a bigger problem, right? You can't keep looping.
exactly. Um,
Think through a basic. What is fundamental in that? What fundamentally makes something 2 to raise to power x?
yeah, I can think that like it should be the solution. Ideal solution would be O of log n complexity. So
Okay, and how's that?
I think I can like do this through recursion.
Did you do any? Did you work with bits and those things in the past?
No, I haven't studied bit operators yet.
Okay, fine. I mean, any approach that you can do, of course. But it will show time limit exceeded if you just do that. But yeah, we can go ahead with that.
Okay, so maybe I'll have a like a recursive function. So I can call it s power of 2 helper. It will take int n. and then I will return is power of 2 helper of n. Here I will okay, that was okay. I want to half the power, right?
Just take the second example, 16, and then try to think around what it was.
Yeah, so if I have 16, then I want to check 16 um that would be the same as doing it iteratively. If I call this function with 16 by 2, then 8 by 2, that will be the same thing only. Um, I need to, I'm sorry, I can't think of a way to do this recursively.
Mm, Okay, and no problem. Just we can move to the next one. You can try the second one that I pasted in the center. Sorry, meeting will the second one which we had skipped earlier.
Okay, okay.
We have
Actually,
done it.
yeah, I just solved it like yesterday only.
Okay. Then maybe we'll just skip that as well.
Yeah.
Mm, Okay. Now, normally when you give interview, just try to open with some new account. Maybe represent.
Actually, in interviews, they don't use LeetCode. They give a different platform. That's why.
We do use so at
Okay,
Walmart, several
sure,
companies we use this.
sure.
Okay. Okay. I'll just have you worked on linked list and all?
Yeah, I have worked with Linkless.
Okay. So can you just try to open this question? Yeah. So basically, you have to figure out the starting point of the linked list. And so basically, if you just go through the description,
Yeah. Given the head of a linked list, return the node where the cycle begins. So if there is no cycle, return null. And there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that the tail's next pointer is connected to. If it is -1, there is no cycle. Do not modify the linked list. Okay. So we only get the head as the input. So this pause value is not given to us, right?
so in the input, you're just given the head. You see, right?
Okay. Yeah. So okay. So I need to return the output tail connects to node at index 1. So I need to return to this node here, right? Or yeah, I need to return this one here. Okay. So the pause is the return thing that I need to return, right?
Right, right.
So if there is no cycle, so I'm thinking I will have to use the like tortoise here concept here, something like the slow pointer, fast pointer approach.
Mhm. Can you just explain how would you approach that?
So what I could do is that I have two pointers in the beginning, and then I increment one of them by one and the other one by two.
Okay,
And I keep doing that. So eventually, if the values are equal, then I will return that index.
perfect, perfect, perfect. So if they meet, then there is a cycle existing, right?
Yeah.
Then what will you do?
Then I will just return the index. But since
No,
this
no.
is a linked list, I need to then I okay, one second.
So the one that you have told is kind of first phase of it. So
Okay.
I mean,
After
it
that,
proves that there is a
I need to take another um, index, another pointer, which will be at the beginning of the array.
perfect.
Then I will just increment both of them by one, right?
Okay, makes sense.
And then both of them meet, then that is the part where the cycle exists.
Perfect, perfect. That sounds perfect. Yeah,
Okay, so shall I give it a try?
yeah. Please go ahead.
Okay, so I'll just make a no, just no need for it. I mean this. So I need two pointers which are pointing at the beginning of the linked list. So this nodes are, I'll just call it P1 pointer 1. So it will be equal to head, but then it will, we're not modifying it in any way. So I think it's okay. Then I'll have a list node star P2, which will also be equal to head. All right. Now, I'll go ahead and do while true. Um, so I will increment the first pointer and make it go to the next. And for the second pointer, I will make it increment two times. So it should be done like this. And then if P1 is equal to P2, then I will break from this while loop. Uh, right. So after that, I will take another pointer P3, which will also be equal to head. Here as well, I will repeat the same thing. And P1 and P2 are equal now, so I can take any one of those and increment it. And P3 also incremented by 1. So if P1 is equal to P3, then should I return the node or the index? Hello?
We need the node, right? Pointer one.
So I should return the node. I think, yeah,
Yeah.
it's node. Okay. So then, okay, we will just break again, or we could simply return it here as well. Yeah, in case it doesn't exist, then I have to return -1. But um, okay, if it doesn't exist, then this loop could run infinitely. That is also a problem.
Hmm.
Okay, but if there is no cycle, then what I can do is if any of them becomes null at any point, then that means there is no cycle because then the list is terminating. So if p1 equal to null pointer, or
What are you trying to say?
what I'm saying is like these are while true loops. So if a cycle does not exist, then this will run infinitely, right?
Mm, can you go up? Like, can you just walk me through from starting?
Yeah. So um, if this condition is never met, then it will keep running infinitely. So to stop, to like mitigate that problem, what I'm doing is I'm checking that if both of them, any one of them becomes null at any point,
No,
then there's no cycle.
no. The line number 15 that you are trying to have while loop, which is kind of an infinite, right? True. So instead of that, why don't you give condition?
Okay, I can give a condition as well, right?
Yeah,
Yeah, so I can just give that condition over here. If P1, uh, P1
correct,
dot next or P1, I think
correct. Perfect. Yeah.
P1 is not equal to null pointer, or P2 is not equal to null pointer, then only
So
we should this.
first P1 will go at the end, or first P2 will go at the end?
The faster one will go at the end. So I think P2 is enough.
Mhm. Also, the P2 dot next can also be should not be there, right?
Yeah,
So when
so
you're
which
standing at the last position, you cannot go
P2
to step, right?
dot next should also not be null. Yeah,
Hmm. Now it's better. Then what do you do after that? You move it, right? Go above. Let me
yeah.
see what you okay. You're iterating. Good. And then you see if it both are equal. Why do you
Mhm.
want to break? Like if they're equal, then do all the operation inside that, right? No need to break over there, right? Line number 20.
Okay, so I can just put this while loop over here.
Exactly.
Yeah, I can definitely do that. So we'll put it here.
You don't need the while loop also. You can remove the while.
Okay, 1 second. This is getting. Okay, if P1 is equal to P2, inside that we have all this. So this will be the closing one. This is closing for the while loop, and this
Why do
is
you need P3? Just keep P1, P2, right? What is P3?
okay. P3 was actually like for the next phase after finding this, like when these become equal, then P3 starts from the beginning of the array.
Mm-hmm.
Uh,
Okay.
so I don't need P3. That means that okay. So um, now what I can do is just increment both of them by
Mm-hmm.
one position, and then when both of them become equal again, then I can return either P1 or P2, whichever one I want, because they're the same.
Mm-hmm.
And in the end, if it is um,
Not cyclic.
if it is not cyclic, then should I return -1? But I need to return a list node.
Just give null. That's fine.
Okay, then I can just return null. Should I give it a try?
You can try.
Okay, so I should probably check for this as well. Mhm. member access within null pointer of type list node. Okay. But I'm putting a check over here. It's still giving null error.
Just think about it.
Sorry.
Just think about it. Why that is happening?
Mhm.
When would this be happening? You can have sysout or anything.
Sorry.
So for which input is it happening? Can you check that?
I think
Which
it
of the
could be happening for this one, first one.
right? Think like in that case, you won't have next dot next, right? Something like that.
So I should put a check over here. If condition. I think that should solve it, right? Is not equal to null pointer. No, it's still there. Okay.
It's not even having next, right? P2 dot next.
Okay.
The one with header, third one, right? Where
But
only one value.
I have put like this check as well. So
Then it should not even go inside in that case, right?
yeah, it should not even go inside the loop because okay, P2 and P1 both are head. Now, while if this is not true, definitely, which is the case here, it is still entering the while loop.
No, see, in the while condition, if any of the condition is true, that will
Oh,
be like
or condition, right? So should it be end?
exactly.
This is my bad. Sorry. So now I don't need this here as well because
Just so
okay, so two of the cases are passing and case 2 is not passing.
at least we made some progress.
Okay, so the problem is, I think with this case, if it is going next to next, this is coming at 2. And it is going next to next, which is here, it will come at 1. This will keep going on forever because they will never meet. Okay, but it is saying that the tail connects at node index 0. So, okay, so it will not go till the end. Huh. So for a case where there are 2 elements, what could be the problem here? So if I just go from the beginning, if I'm at 1, both of them are at 1, then it goes to 2, it comes back to 1, then it comes to 1, and this it goes to 2, it comes back to 1, this goes to, then it comes back to 1. Yeah, right. So actually the tail connects at node index 0 only, right?
Right.
My output is saying it is connecting at index 1.
That's what needs to be fixed.
So I think this part is working fine. But when I come inside this part, if I start from here, if I increment both of them, then they will of every time be the same. So it will return the next index, right? Which is causing this problem.
So what condition can you add? What you can do with it?
Okay. So we know that P1 and P2 are equal. If we increment both by 1, then this will always hit on the next iteration itself. which is causing the problem. Hmm. Should I just like maybe do the same thing here twice?
Mm,
If I run
I don't.
this,
I don't think so. That's
yeah, I don't think so either. Um, so um, okay, okay. Um, if I is equal to,
once both the pointers are equal, P1 and P2,
yeah,
right?
yeah.
After that, basically, maybe you can just have a while loop where you can say like your P1, their pointer is not equal to the slow one, right?
While P1 is not equal to P2, but um,
You have a pointer which starts at head. Can you introduce a pointer which starts at head?
yeah, actually, that is what I was doing earlier. Like,
Yeah, yeah, you can do that even now because this condition would not pass until then. Right?
yeah,
Yeah, just
so
have a pointer which goes to head. And then you have another pointer which is already there with you, the slow
P1,
pointer. Yeah,
and
the
while
slow
they are
pointer is there.
not equal, I can increment P1 and P3, and if they
Okay.
are otherwise, I have it in the while loop. So if they are equal, fine, I can keep this if statement and return P1 or P3, whichever one I want, and
No, no,
then
in that while loop, you're already checking until they are not equal, right? The while loop would fail once it is equal, correct?
so I
So
think
once
this
it is equal, it just turn
the last,
the,
right?
that is very outside, I think, right? Just after the while loop, you have to add.
Yeah, so here
That is at the null level, return null level, right? So that is a separate thing.
I have to return the null value. Right.
Perfect. Now I think this should work for you.
Okay.
And what are you returning? That P3, P3 or P1?
P1 actually.
Think about
Should
it.
return P3.
P3, right?
But both of them are equal, right? So
Oh, scope is not defined, is it?
scope is not defined.
What is the scope of your P3? Keep it outside the. No, it's
It's
fine. I think it's at the right place.
use of undeclared identifier P3.
Okay, P3 you just define at above level. You have already defined that, right?
Yeah.
So here, why it is saying like P3 is not under the scope. Check the if bracket. Where is the bracket ending? Line number
Oh,
19.
there's something wrong with the bracket. Actually, I forgot to put a starting
Yeah,
bracket here.
no
Yeah,
problem.
should be fine.
Happens.
Yeah.
Check the if bracket 19 number.
Hmm. Okay, there's another problem. Okay, this is fine. Then this is for the while loop. Oh no, I should put another bracket here.
Uh,
Then
Please
this and while loop, and this would be the function, and this would be the class, right?
be careful with these things.
Yeah, sure. Okay, now it's working.
Perfect.
Yes.
They should work. No doubt in that. But
Oh, it's actually not.
you still have a condition.
Sorry.
You still have one condition failing, right? Okay.
Yeah. Tail connects at node index 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is where the tail is connecting to. Okay. That is my output. And it's actually at 6. So 9, 8, 7, 6. It's over here. It's very hard to figure out without a diagram. Um, okay, so it would be from here to here. That's how the tail is. But it's returning this as the okay. Mm,
Think, yeah, I mean, your code is almost correct. Just one or two things needs to be updated. That would fix it.
okay. Is this extra condition? Should I remove it?
Yeah, exactly.
Yeah. Okay. I'll use it with this test case. Okay, it's still not working fine. So I have P1, I have P2. I'm incrementing one by one and the other one by two. Then if they're equal, I make a new value, a new pointer which is at the head. And then while they are not equal, while P1 is not equal to P3, okay, then P1 becomes next.
Uh, in the while condition that you have given above, line number 15,
Okay,
instead of having those null pointer checks, you can just give like P2 and you can give like P2 dot next exist. That's it, right? No need of null pointer check.
so
So
this,
yeah, and yeah,
is this not the same thing? Is it somehow different?
just to simplify the view, that's what I just.
Okay, okay. Hmm. So the problem is still there. Okay. While P1 is not equal to P3, I am incrementing both of them. So in this case, okay, I need to. So
Uh,
eventually,
code is fine, I believe. Just try to run it once. Most of it is fine.
I think I'm missing a edge case.
Hmm. Okay.
So tail connects at node 6. So it is going from here to here, but it is simply returning this part. So it is returning uh, the starting of the cycle, not the end of it. Okay.
Um, okay. Can you also add one more condition in the beginning? Like
This
if you
value.
had no, I mean like, can you just add one more condition
Okay,
in the
here.
beginning for head? Your head is there, right? If it's not head, and or you can add with head dot next doesn't exist. Give our condition
Or okay.
or condition.
Oh, sorry.
If head dot next doesn't exist. So in this case also you need to return null, right?
Yeah, but here both of these are not really causing
Correct.
the.
It's not related, but still just a validation check.
Okay, sure. And so
Any
I
feeling?
I can't figure it out. Like, what's the problem?
Can you go over? Let's walk through once again. So just
Okay.
one last try. So that null check is fine. It doesn't have to do anything with this. Then
Hmm.
you have two pointers created,
Hmm.
fast and slow pointers. And yeah, then you're just having a while loop, which is having a fast and fast dot next. Then you're just doing next, and then for PT you're doing next dot next, right?
Hmm.
Now if your fast and slow matches, then what are you doing is like you're having another pointer created.
At the head,
Yeah, and for that pointer, you're just checking like
like incrementing both by one, and when they are not equal, then I'm returning P3. I think this part is there's something wrong with this part, I believe. Um,
equal to slow. Okay, P1 is not equal to P3.
no, I think it's actually it looks fine.
Yeah, looks. Then you have the brackets. Can you check? The while loop ends there. 28.
Yeah,
Yeah,
the
where is
okay.
the definition ending?
If condition is ending here, while is ending here, and the bigger while is ending here.
Hmm.
Okay, functions are fine, I believe.
In 23 line number, we are checking for P3 not equal to same thing, right? Either ways.
Yeah.
So pointer.
Okay. Actually, there's a similar problem where we have elements of an array from 1 to n. That's a like bit different from this, but it's the same concept. I used the same code there; it was working. There's something I'm missing over here.
Hmm.
Mhm. Oh yeah. So sorry. It should be p3.next.
Crazy, crazy.
Oh my god.
Good
Sorry.
catch, actually. Yeah.
Yeah. Yeah. Now.
Great. Awesome. Awesome. Just a silly mistake. So yeah,
Hmm.
that's good to me. I mean, the interview extended more than the design time, but yeah, it was a good one.
Actually, we started at 3:10, right?
Sorry.
We started at 3:10.
Oh yeah. So we are almost at the right time.
Yeah.
So yeah, I'll just share some feedback with you. And so I think overall it was great. I think you have worked a lot on your coding skills, and that's a good sign going
Thank
ahead. And yeah, just the only thing that I would like you to improve is the introduction that you give in the beginning. So try to
Sure.
make it elaborate. You just include very little amount of things. I mean,
Sure. Sure.
just did so quickly. So it has to include your curriculum, project details that you have worked, at least the technologies that you have used in that projects. You have used them, but still you have to explain it in more details. Like it
Sure.
should be at least 2 or 3 minutes long. 3 minutes long. Okay.
Definitely. Thank you.
So yeah, just increase that. And other than that, I think you're doing great. Just work on your coding skills even more. I think you're already doing great. Better than I think most of the people around that I've taken interview of.
Thank
So
you.
yeah, you're almost there.
Okay.
Yeah. Let me know
Okay.
if you have any thoughts. Yeah.
Sure. Thank you very much for your time.
Okay.